Surface High-Speed Opti Rough is a unique toolpath in that it takes large Z-steps down using a dynamic milling motion, but then will take a shallower Z-step up, profiling the part and reducing steep stair steps and getting us closer to a net shape for some finishing ops. Let's just take a look at a verify here of an Opti Rough. You'll notice that it takes a very large initial step down, removing a lot of material, but then we'll take smaller step ups, profiling the part. Once again, large step down, eliminating the bulk of the material, and then some shallower step ups to better follow the contour of the part. Now this was a core shape. Let's take a look at a cavity type shape. Let's create this Opti Rough toolpath from scratch. Start by going under Toolpath, Surface High Speed, Drive Surface, pick the entire model. Containment. I just want to keep it inside the cavity region. Pick my green chain. And then Toolpath Type, Opti Rough, Tool. Go into my library and grab a 3/4 inch bullnose end mill. Now let's go ahead and set the feeds and speeds. This part's aluminum, and remember this cuts in a dynamic milling style, so I'm going to be taking very shallow step over, but cut at a high rate of feed. So let's say 200 inches a minute, plunge rate of 20, then my spindle speed, let's say 10,000 RPM. And then my cut parameters. Now first my step down, I'm going to be very aggressive here, take 1.25 inches. But the key to this, these high feed rates and this deep step down, is the step over. We need to set that very shallow, so 10% will work for us. Now personally, I've cut with these parameters and I know that they do work and they work safely. And our toolpath radius, click on this field, you can see it's that arcing motion. I'm going to set this to 45% of the tool radius, which is a common setting, and then step up. We'll turn that on. I'm just going to leave that at 10%, so it'll take 75,000 step ups after it took 1.25 inches step down. And then my stock to leave on walls, we can leave that at 50 thousandths. But the one thing I do have to check is my arc filter tolerance. Remember, I want the arc filter to be about half of my stock to leave. I'm going to go into refine here quickly. And since we're roughing, I want to create as much arcs as possible. So I'll turn on my line arc filter, create arcs in XY. Turn up my maximum arc radius that my machine can take, which is 1,000. And then we'll set the total tolerance here to 25 thousandths. Now I don't want to plunge 1.25 inches right into this part. I need to set how I'm going to be entering. That's in the transitions page here. Now I can either helix or use several other options. I'm going to pick profile here, which will basically give me a ramping slot type motion. And the plunge angle, we'll set this at, let's say, 5 degrees. And then my entry feeds and speeds. I'd like to reduce this a bit so I get proper chip evacuation before I get to the floor of the part and really start machining. So let's reduce that feed rate to 75 inches a minute. I can leave that spindle speed still at 10,000. Then I'm going to have a bit of a dwell here. Let's give it a 2-second dwell. This will make sure that all the chips will be evacuated from my initial slot, so when I start machining at that 200 inches a minute, I'm not going to have any residual chips in there. Take a quick look at my linking parameters, and I like to have this set at minimum distance at a feed rate of 500 inches a minute, which is the maximum my machine tool can take. And we'll tighten up the arcs a little bit here as well, just to speed this up. And then I think I'm all set. We'll take a quick look at the back plot first. And we can see that entry motion, that ramp. And then there's my step over of 10%. But remember, I'm feeding at 200 inches a minute. And I have my arcs in my back plot. Those are turned to orange. Linear moves are blue. So this is all arc moves. So this machine is really going to be moving in a nice fluid, high-speed manner. And I'm taking that 1.25 inch step down. Then it goes through and takes those shallower step-ups, profiling my shape a bit. Let's go into Verify and take a look at this. There's my step down, and then nice step-ups. Big step down, then small, efficient step-ups. So with this one toolpath, I was able to very aggressively rough this part, but also get a lot of the finer details roughed in here too. Now the regular way of cutting this would be with like a area mill toolpath, pocketing this out, and then having to go back in with a rest milling operation or two to smooth out the aggressive stair steps. But this one Opti Rough takes care of all of that. Now there's one more important detail we need to look at with this toolpath. Now this was a cavity shaped part where my entry was a ramping motion. If we go back to the previous part, this is a core shaped part. I don't want to enter on the part. I want to enter off of it. So if we backplot, we can see entering at the side there and then working my way towards the center. Now the toggle that actuates that is here in the parameters, cut parameters, and that's this, use core mill passes. That starts from the outside inward for these standing boss type of features. If I were to turn that off, regenerate, you can see I'm profiling actually on the part multiple times, working my way around. Not the ideal way to machine this. So really keep in mind that core roughing toggle, whether you're machining a boss such as this or a cavity such as the previous part.